Here we have a SAT math question on triangle. Okay, let's go with the question. A triangle has a base that is 65% of its height. If the base were decreased by 13 inches, how the height need to change to keep the same proportions? Okay, first let me draw a triangle with the height and base. Here I have drawn a triangle. Okay, so the height of the triangle is not given. So we can assume any value as a height of triangle. But here this problem is based on percentage because the base is given that is 65% of its heights. So whenever we work out a problem based on percentage and there is an unknown quantity, so we can assume 100 as an unknown quantity because it will be easier for us to do further calculation on percentage. Okay, so let me assume the height of the triangle is 100. So if the height of the triangle is 100, what is the base of the triangle? So the base is 65% of the height. So the 65% of 100 is just 65. Okay, now I have the base 65 and the height 100. So the ratio between the height 100 and the base 65 is 100 to 65. Okay, now so according to the question, the base has to be decreased by 13 inches. If the base is decreased by 13 inches, what is the new base? It will be 65 negative 13, so which is equal to 52. So 52 is the new base. So when we decrease the base by 13 inches, how much the height has to be changed? So the height also has to be decreased. So I assume the height has to be decreased by x inches. Then the new height will be 100 negative x. Okay, so when the base is decreased by 13 inches, it becomes 52. At the same time, I decrease the height by x inches, then it becomes 100 negative x. Okay, so after these changes, so in whatever ratio we have the original quantities, so the changed quantities also must be in the same ratio because the question says how would the height need to change to keep the same proportion. Same proportion means, so the ratio between the original quantity is 165 and the ratio between the changed quantity is 100 negative x and 52 must be same. So let me equate this ratio to the ratio of the changed quantities, that is 100 negative x to 52. Okay, so to solve for this equation better, we can write the ratios on both sides as fractions. Then I'll be getting 100 over 65 equals to 100 negative x over 52. Okay, here both of them are multiples of 5, so better we can simplify this. So when I divide 100 by 5, I'll be getting 20. When I divide 65 by 5, I'll be getting 13. So I'm getting 20 over 13 equals to 100 negative x over 52. Okay, so now we can do cross multiplication to solve this equation. That is the numerator 20 over here has to be multiplied by this denominator 52. Then I'm getting 20 times 52. On the right side, this numerator 100 negative x has to be multiplied by the denominator 13. Then I'm getting 13 into 100 negative x. So now I have to multiply this 20 and 52. I'll be getting 1040, and 13 times 100 is 1300, and 13 times negative x will be negative 13x. Okay, so now we have to solve for x because x represents so the amount of change we have made in the height, because they're asking us to find how would the height need to change. So how much we have to change in the height. So we have assumed x as the change in the height. So we have to solve for x. Okay, for that I subtract 1300 from both sides. When I do so, I'm getting 260. When I simplify 1040 and negative 1200, I'm getting negative 260. On the right side, I'm getting negative 13x. Okay, to solve for x, I divide both sides by negative 13. So this negative will cancel out. 30 goes into 31 times, 13 goes into 13 one times, and 13 goes into 26 twice, and we have 0 over here. So this negative 13 will cancel out. I get 20 equals to x. Okay, to keep the same proportions, the height has to be changed by 20 units. That is, the height has to be decreased by 20 units. So, so that is here we have x equals to 20. If I plug in x equals to 20 over here, 100 negative 20 becomes 80. The new height is 80. So that means the height has to be decreased by 20 inches. The correct answer choice for this question is option D.